In this video, we will present the main functional blocks that are present in any communication system, both in the transmitter and in the receiver. In the transmitter, there are four basic functional blocks: the source encoder, the channel encoder, the interleaver, and the digital modulator. And at the receiver, we have the four counterparts of these four elements: the digital demodulator, the interleaver, the channel decoder, and the source decoder. Now, we will describe briefly the main function of these elements. The first element is the source encoder, and this element basically generates the binary information that we want to transmit, the sequence of bits containing this information. The source coding typically includes some kind of reduction of redundancy, some kind of compression to reduce as much as possible the data rate that is necessary to transmit the corresponding information. Some examples of source coding are MPG or DivX for video, MP3 or OGG for audio, ZIP or RAR to compress files. These are just some examples. The second element is the channel encoder, and the main role of a channel encoder is to allow the detection and the correction of possible errors that happen during the transmission. To do this, it is necessary to introduce some kind of a structured redundancy, and this structured redundancy will allow to detect errors and to correct errors. The simplest possible channel coding is repetition codes. Every bit of information, a 0 or a 1, will be repeated and will be transmitted several times. For instance, 2 times, or for instance, 3 times. It is possible to detect that an error has happened if in the block of n bits that has been transmitted to transmit an information bit, there are at least one error, and at most the number of repetitions -1. If we transmit every information bit 3 times, as long as we have at most 2 errors, we will not receive the same block of 3 equal bits. Therefore, we can detect up to 2 errors. With a majority decision rule, it's possible to correct up to 1 error in every block of 3 bits. Because if we transmit 3 equal bits and we have a single error, at the receiver we'll see an erroneous bit, 2 correct bits, majority decision will work. Obviously, practical codes are a little bit more complex than repetition codes, but the idea is this one: to introduce redundancy, allowing to detect and to correct errors. And as seen in this example, the codes work much better when we have a small number of errors per coded block. Taking this into account, now we can introduce the third element, the interleaver. And the interleaver is designed to protect about errors that happen in bursts. And it works in combination with the channel encoder to detect and to correct errors. Taking into account that everything works better in a channel encoder, if we have a few number of erroneous bits per block, the role of the interleaver is to rearrange the bits before of the transmission, and then at the receiver the bits are rearranged again to recover the original order in such a way that errors that happen in a burst are converted in isolated errors. There are different kinds of interleavers: block interleavers, convolutional interleavers. Here we will present an example of the behavior of a block interleaver. Here we have the information data. We will use a repetition code where every information bit will be transmitted 3 times, and here we have the interleaver. The data is organized in a matrix, The data is introduced per column and is extracted per row, and this generates an interleaved data sequence. This data is transmitted, and maybe errors happen in bursts. Here we have a burst of errors. At the interleaver, again, we introduce the information per columns, we read out the information per rows, and we recover the original order of the transmitted bits. And with this rearrangement, now these errors that happen in a burst are converted in isolated errors. In this example, a single error per block, where the repetition code will be able to recover the original data by majority decision. And finally, the last functional element that we have in the transmitter is the digital modulator. And the role of the digital modulator is to convert the bits that we have at the output of the interleaver in a signal, an electrical signal that is appropriate to be transmitted in an analog channel. This is the main function of the digital modulator.